Welcome to the Continuous Delivery Podcast. My name is Zarar. Chaba is not here today, but we have a very special guest. It's Brad Smith. He is the author of the amazing book, which everybody should read, DevOps for the Desperate. It's available on Amazon. And he's currently a senior director of engineering at Barrow Bank, and he's formerly a senior engineering manager at Amazon. Welcome to the podcast, Brad.
Hey, thanks, Zarar.
So we skip the small talk and we get right into it. And one of the things that we sort of talked about in our pre-podcast chat was this concept of developer productivity. And I'm going to make this podcast a little bit more helpful for me because I've, over the last 18 months, started a company called Jump Comedy. And I'm encountering a lot of kind of growth challenges at this point where we're sort of scaling, we're doing quite well. And now we have some certain decisions to make. And one of the decisions is we got to hire another developer because I can't do all the work. And I'm really torn on this one because so far I've written all the code for the site, for the mobile apps, for the web, for the backend, all that. And now I want to hire another developer. I'm going to pay them whatever, a good amount of money. And I expect them to do basically what I did. Ideally, I want to see 100% improvement in productivity. Sort of our incremental developer productivity should be a ratio of 1-to-1. Obviously, that doesn't happen. And I just want to get your thoughts in your experience. Why does that not happen? And if you were in my position, what would you enable in my company to make sure I get as close to 100 as possible? A lot of meaty questions. So go for it. And there's no time limit for you to answer this.
Sure. Let's take the first one. The first part first, that why does this happen? Why is this mythical person hour actually exist? And a lot of it is, like you kind of said, you're the only engineer, you're the only one creating this stuff, so all the cognitive load is in your head. You can hold the whole domain in your head, and you can pivot in context between problems or features or whatever you're doing. And it also follows your pattern of thought, how you learn. And that works great for you, allows you to go fast. It's obviously not a great experience for somebody coming in new. And I think the other part of this is that when you're in a startup, you're just trying to survive. So you're going as fast as you can. You're working all different hours, you're doing whatever it takes, clawing and scratching to try to get customers. And I think when you bring people on, you think about the onboarding experience. So let's transition into what I think are some like very actionable things that you should be doing, or other people in your spot should be doing. When you bring people on, I think one of the biggest misses I've seen in 20-ish, 5+ years or whatever is onboarding. And the idea is you want to bring somebody on who's actually going to go from 0 to, 80% of what you could do. And that is hard because there's all that domain knowledge, there's all that transfer and everything. And a lot of people in startups don't take the time to write documentation, run books. You don't have this grand 90-day onboarding, soft landing for people. So they learn about the domain and then learn to keep it in their head like you. If your engineering efforts are crossing multiple domains, just think how long it took for you to figure that out and to be able to reason about it. And then we expect these engineers to come in and do that same and fast. And so onboarding is someplace that I always think that is a miss for people. And onboarding could be as simple as setting up, multiple sessions per week for these people to come on, and you are just going to not just like word salad or brain dump to them, but actually have some sort of growth of increasement of knowledge. Start off a little small and then increase generally as you go. There's also, getting your system set up, being able to actually jump into the code. All that needs to be accessible. And then when it's just one or two people, you don't realize some of the habits you develop or where you make it difficult for new people to get up and running fast. And so onboarding, I think, is a great place for you and other people to start. Hey, if I was an engineer and I was coming on, what things would I need so I can jump in this code base and actually add value? What are these features our customers want? What knowledge would they need to know? And then really target that. There's no way that they're going to learn the whole domain in business in 30, 60 days. They're just not. So if you, on the onboarding, if you target exactly what they need to be and cut out a lot of the fat that you had to go through to get there, it's hard. It's not perfect. I think a lot of people struggle at, I do. How much information is too much? And plus you have all the other information from the rest of the company, like HR, other benefits and all those other things that cloud that as well. So here's the first thing. I'll pause right there and see if you.
No, the onboarding is essential for sure. And there's parts of onboarding too. There's the aspect of the domain knowledge, which is a different category of a problem than the onboarding of the actual get your development environment set up to working. I think in companies like that alone takes like 4 weeks, just to get, especially if you're using like some cloud environment, which is you're deploying to like a CDE or something like that, and that's forever. But then the part that worries me is like the reason the code is doing something that may not make sense to you when you first look at it, right? There's always certain things in the code base where you're doing some sort of a check, or you're doing some sort of a algorithm where it's not obvious what it is doing. And I think even though it's sort of tested, it's not necessarily obvious. So I think there's an 80-20 problem here, where 80% of the stuff you could probably just get away with by just doing a lot of pair programming, some documentation reading, some onboarding, having good tool set. But there's this 20%, which I think now that I'm vocalizing this, is sort of related to the technical debt in the code base. Because if you have to spend time in explaining your technical debt and why it's technical debt, I think that's the part that is not natural to newcomers. Newcomers can read a class, they can understand what it's doing. A relatively senior person can sort of figure that out, but they won't figure out why you're doing a weird double loop against something when it doesn't really make sense. But that's probably a factor of something that happened in the past, and there was a reason for it at the time. That's the part that sort of, I feel like, where we spend a lot of time explaining to developers why the code is so crappy in certain areas, and that kind of throws them off.
Yeah, no, it's a really good point. And the other thing that's missed too is people learn different ways. Like, for example, I'm a very visual learner. You can't just give me a bunch of documentation where I have to read and go do it. I'm not going to learn that well. But if I go pair with you, or I go watch something, or I get my hands into the code, I learn so much faster. But other people can read an RFC, read something, and then grok it immediately and then be things. So you got to plan for how people learn. Obviously, asking it in the beginning is a great thing. But obviously, I mean, besides the normal standards that we should have, like testing, like tests should hopefully kind of document some of the way the code is. I know when I started a long time ago, comments in code were great. Then we went through a phase where comments were terrible. I think where people are coming back to, like, yeah, I think if it's some weird domain or functional or double loops as you reference, I think it's okay to put some comments in there.
I do. I think there was this idea somewhere in the middle where comments are a violation of DRY, like
Yes.
don't repeat yourself. And so I started naming my functions like, send email to customer when they have not signed up for the, like these 20 word. I was like, hey, comments are bad, so I got to replace something with comments. So I'll just have really long function names. But I do find that comments serve a different purpose than function naming or class naming. I think it's I just want to get your opinion on this. I think it's too much to ask of a developer to look at a method name and a class name in context of all the other things and sort of understand just by naming what the thing is doing.
Yeah, I agree with you. I think, it's funny. I think earlier in my career, every time I looked at like clever code or clever stuff as an engineer, I was always like, oh, this person's so much better engineer than I am. Like, oh, it's amazing. Look at this code. And then, of course, as I've gotten older, I realized like, oh my God, it's so unmaintainable. And I think striving for simplicity, whereas like, sure, hey, this function is maybe got too many parameters, or maybe it's a little bit longer. It breaks some sort of solid principle here or whatever. But as long as it's readable and it's manageable, and then you can edit and update it in the future, then I think it's fine. And I think, honestly, I think we probably as an industry worry too much about some of those things.
I call that lowest common denominator coding. And it sounds like a bad thing because lowest common denominator means that you're getting the worst of the worst, like what Edward. But I think there's an element of truth there where you got to write your code in a way which most people have the background to understand. Like, for example, recursion is a great example. Recursion is a tempting thing to implement, but even though it's simple in your head, maybe you liked it, you learned it in school, you kind of love it. Most people don't use recursion. There's no point in you writing even though it might be quote unquote more efficient or use less of the stack or whatever, it's still a bad idea to use it because people don't really understand it. So I do agree that, but simplicity is such a word which you can throw so much things around. It's so up for debate. What does simplicity mean to you?
Oh gosh. So for me, simplicity means breaking domains into smaller domains, right? You can't, like, for example, in the SRE space, which is where I've spent a lot of my career, and before it was called SRE, DevOps, and along those lines, and we can get into like how marketing has destroyed both those.
Let's get into that. Let's get into that.
I think for me, it is being able to keep what we're doing in my head. I can only keep so many things in my head. I can only understand so much. And if you're trying to keep the whole universe and everything in there while you're trying to go fast and while you're trying to solve problems, because let's back up just even one more step. There's engineering, like I write code or when I'm building stuff for myself, it's completely different from when I get paid to do it. And I know some people may really snarkle at that a little bit, but I get paid in my day job to solve business problems by using some engineering practices, by writing software. And sometimes it's not the stuff that I really like to do or is great, but it's a part of being a professional engineer and you have to do those things. Now, when I write for myself, I'm doing stuff, I'm way more creative and I'm solving different problems that I like. I'm scratching my own itches instead of these other customers. Now, sometimes you get lucky, you work at a place that you really believe in the vision, you believe in everything else. And so those kind of meld together and those are special. But they don't always happen all the time. But I think so. To answer your question more directly, simplicity is being able to break down the domains so everybody on the team understands them. Code is simple. It doesn't have to be beautiful. It doesn't have to be. It should never be clever. And as a person, I shouldn't need an IDE with all these plugins to be able to follow happy paths how workflow is coming through and in. If I have to jump and open up all these tabs just to figure out how one call is coming in and they're jumping around, then I think we've done too much. I think creating microservices for the sake of creating microservices when your growth and everything doesn't call. You're not going to need gRPC. You don't need Kafka. You don't need GraphQL. Where JSON and simple REST will do the job, and on an EC2 instance, you don't need EKS. And so I think you can always add complexity, but the inverse is so much more difficult. And I see that more now than I ever have in my career is the over engineering and stuff. And I get it. There's a lot of books and YouTube and other things out there that say, hey, you need all these things. You need microservices. And then I'm sure you've seen it. Most people implement microservices where you just basically a distributed monolith where they're all still dependent on each other. But now you've made, releasing, testing, and onboarding way harder than it needed to be. Hey, one thing I wanted to tell you, have you ever heard of Ladder's lightweight architectural decision records, LADR?
No.
Okay. So this is something you need to start doing now in your business before you hire somebody on. This is one of the greatest little small things you can start doing now. You basically, a lightweight architectural decision record is put it in Git, whatever, make it super small and short. We chose MySQL on this day because of this reason. We also thought of Postgres and blah, 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 but decided against it because of these reasons. That's it. That's all you put, right? Now, say you hire me. I come on, I start working, and I'm like, well, why are we doing this? What are we doing this? I literally can go back. It is like a git commit history of all the decisions you've made without tons of data. It takes you 2 seconds to put one up. And it is so powerful, impactful. I learned this years ago. Somebody else taught me this. And now I take it every job I go to, everywhere I go. And it is so impactful to get people up to speed. Because, people like, you've been at a job and you'd be like, why are we using Kafka? Boom. I could tell you exactly why somebody made those decisions. Whether you agree with them or not, at least you have that information.
Yeah, because I think every decision, even though in hindsight it may look suspect, at the time there was a good reason for it.
100%.
And I think most of the time you struggle to recall, even in a one-person company, you struggle to recall why you made it. And sometimes you put a comment in there, but a comment is describing a very specific thing. But I totally get it. And if it's in Git, it's versioned. Even better. I know that on Hacker News, I saw this thing called the architecture.md, but that was more of like a kind of like a readme.md. He was like, you should have an architecture.md, but that's more of like a current state, which is not what you're talking about.
Yeah, no. People want historical. They want to know. And then it's how our brains work, right? It's how we build, we stitch all that together and go, oh, now I understand why we're here and why we made these decisions, because it speeds my onboarding up.
Yeah, I mean, on microservices, I think the industry, I have seen a shift sort of away from microservices now, and I think it's a lot because of testing. Because it's so difficult to test any sort of full transaction in a microservice context. There's so much mocking you have to do, and which is I love mocking, but when you're mocking like 8 of the 9 things that the microservice is doing, then what are you even testing at that point?
Right.
And I do like the shift to mono repos because it sort of increases code reusability. Testing becomes easier. It just you sort of just as a developer you feel more confident in your commits in a mono repo context because like it's integrated with more things. And so going back to the simplicity versus complexity part, a couple of weeks ago we had John Oosterhout who wrote the book Principles of Software Design on the podcast, and he's a complexity guy. And one of the things he talked about in complexity was dependencies, which add complexity. But he also mentioned cognitive load, which is that the amount of things a developer has to worry about when they are doing their job. If it's a lot, it doesn't matter how senior you are, you're gonna struggle with it because there's only so much a human being can do. But let's go into the topic you kind of alluded to is SRE versus SRE. Can you give us a bit of a history lesson why you set that on? It used to be DevOps, now it's SRE. Because when I read the Goal, the old classic book, and then I read the Phoenix Project, which sort of introduced these DevOps concepts, and then there was the Unicorn Project as well, which got quite popular in the management hands. The fundamental idea behind DevOps to me was instead of this wall between development and operations, it's the development team that also owns the operation. You kind of break down that wall so that it's basically you get rid of the gate. And now you own the code that's running in production. Tell us how we got from that sort of fairly simplistic concept of early DevOps to where we are today with SRE, and why that transition happened, whether you agree with it or not on the labeling. How did that transition happen, and how do we get to where we are today, where you have dedicated SRE teams managing production software? Give us a bit of a history lesson there.
Sure. So, I think DevOps was first coined in 2011. It was kind of said out loud, and like we said, it is to break down the difference between operations and engineering, software engineering. But those were different times. Those were data centers. Those back when we actually had to rack servers and worry about network cables and patching. Like I still have problems with my fingers for trying to put the rack little the screw holders in on the racks where like it hurts so bad. And people, I'm sure some of your audience who did this are going to remember all the pain. And then of course, 2014 Docker. Obviously we had containerization before and BSD jails and Elixir containers. Of course, they productized it, and then everybody started buying in, and it was a way to, hey, it works on my machine and allows developers like, hey, I'm tired of having other people in the critical path. Then, cloud, Amazon happened, and all these compute services that you can get cheaper, you can spin it up, you can scale up and down. Everybody knows that probably takes it for granted nowadays. So it changed everything. I think Google also, came out with what they believed was a site reliability engineering. They've written 2 books on it because it solved their problems, right? And at their scale, they needed people because they couldn't have engineers be polyglots in the sense of, or generalists, I should say, in the sense of, hey, they have to know everything. You're going to know about disk performance, IO, you're going to know all this stuff, and you need to solve all these business logic. And I think this is kind of, we talked a little bit about this earlier. I think this is a transition. So when I started, early 2000s or whatever, you kind of had to know everything. I had to rack servers and plug stuff in, write software, monitor, do all these things. And you're right, it was very waterfall. People would throw stuff over and I'd have to manage or do things that I didn't even know or understand how they really worked or how it affected customers. And so you had all that. And then we went to a point where then everybody was specialized. So we hired I only do JavaScript. I only do front end. I only do back end. I only do database. And it was all this specialized stuff. And I think we've gone through that. Not to self-plugging, but I wrote a book 2 years ago that got published on No Starch Press, and it was called DevOps for the Desperate. And it was because of what I've seen in the marketplace of engineers moving so far away from the metal that they have forgotten basic things like how your code goes from your editor to the customer. And I saw this gap in that we were growing. Those boot camps came about, in the 2016s, 2018s, people were going, and we were missing this fundamental things of how delivery, how computers work in that sense. And we were just so focused on web. I think we're seeing it right size. I think we're seeing the pendulum come back the other way, where companies are unfortunately laying people off and expecting engineers to know more. You need to be cloud native. You need to understand Kubernetes. But I think to answer your question a little bit more directly about SRE and DevOps, I think companies misunderstood and they just saw trends and they're like, okay, well, we have this DevOps or system administrator or system engineer role, and we're going to call them SREs because that's what people are looking for right now. And this is the way the market is going. And so we're going to hire SREs, but instead of actually worrying about production systems, they're coming in and building infrastructure, writing Terraform. And there's nothing wrong with that. There's absolutely nothing wrong. But there is a mismatch if you want a person to come in and deal with just production. I always like to look at the split like this. SRE, if I was going to have an SRE and a DevOps team, the SRE team would be to the right of production, everything from production to the right. And they're working with teams. This is tracing, this is reliability, this is performance tuning and all those things. And they're only focused on production, where DevOps would be everything from local development all the way up into the lower environments before production. And that's pipelines and everything else. Teaching those good habits, like you were saying earlier, that we were trying to teach is, infrastructure as code, configuration management, all the stuff that we've got from the DevOps movement early on.
Yeah, I mean, we talked about cognitive load earlier, and I personally hate specialization, especially at the programming language or stack level. I think that's just, there's absolutely no reason why you cannot learn 2 or 3 languages proficiently as a software developer, even if you are at an intermediate level. That's just no excuse, frankly. And I think if you're somebody who kind of classifies themselves as a React developer or an Angular developer or a Java developer, I frankly think you're doing yourself a disservice, because the other ones are not that difficult to learn, frankly. I know there's a browser context, and then there's like a server context, and there's a lot going on with the browser. And I understand that TypeScript is a very powerful language, and it has its own quirks. And yes, you need specialization, but it's not that complicated. But at the same time, while I argue against specialization here, I sort of see why the production monitoring observability aspect is different, because it is a lot of cognitive load. If you're spending your 9 to 5 developing software applications, send them to prod, it's sort of a lot to expect of you to actually go ahead and I think you should write good code, which is observable, but the actual observability, I can see why it's a separate team.
Yeah, and it absolutely. But here's the dirty little secret, right? If you're Amazon or you're Google, you can afford to hire all these specializations, right? It makes more sense. They can go faster with having people just deal with a problem. But as for the small to medium sized startups or businesses, you can't really afford to hire all these specializations. So you've kind of got to blend. You got to blend a little bit of these practices, and like DevOps is just all about getting code to the customer in a safe, repeatable, smaller incremental way, right? As I'm sure you remember years ago, people were releasing once a month and they would pile up all these releases into one thing, and then you'd ship code and then things went wrong. You got to roll it all back, or you're cherry picking stuff out. And the DevOps movement obviously changes. Say, hey, we taking things from lean manufacturing like Toyota, and saying, hey, actually, if we control the flow of work coming in all into one spot, we can go much faster. And if we make small changes through the way, we'll find problems faster and we can fix problems faster. And I think that has obviously caught on. I think everybody agrees with that. But I think having engineers understand the internals of Kubernetes, operators and YAML files and all the stuff. While I think an engineer understanding how to write a basic YAML file and stuff for some configuration management or IAC, I think is completely reasonable. But understanding Istio, networking, how the blue-green canary pipeline, it is way too much. It is way, way too much for them to not only to keep that domain and that cognitive load in, all in their head, but to be good at it. How do you expect people to be like, you want them to solve complex business problems, but then you're going to solve these even more complex, possibly, infrastructure and delivery and release problems. I think it's a lot to ask.
Yeah. You kind of alluded to earlier about how, SRE was there to solve Google's problems at the time. Now, going back to kind of my context a little bit, my problems aren't that sophisticated. They're not that complicated.
You don't say.
And, so right now I'm hosting all my stuff with DigitalOcean, which is probably one of the cheaper providers of infrastructure out there. And now we are about to serve like multiple locations because we got shows in the US. So now we're thinking of, right now we just have servers in basically in Toronto, and that serves the Canadian market well enough. But now we're going to Miami, and so we kind of need to distribute our infrastructure. And immediately the first kind of like solution that pops up was like, okay, I mean, it's already containerized, but it's just dumped on a DigitalOcean app platform and it kind of runs there. So now that you're kind of at this startup stage where you're going from like Canada to North America, maybe your customer base has grown by, I don't know, 4,000 kilometers or miles either direction. What are the questions that I should be asking myself when I'm like, okay, now I got to move from Canada to the US, and we also have some shows in the UK. So I want my app to be performant in the UK, in Canada, and in the southern United States. Right now, current state, everything's in like one data center in Toronto under DigitalOcean. It's a package. All the applications are packaged as in Docker containers, but we're not using K8 right now. Should I be jumping into K8? How should I be thinking about this? What questions maybe should I be asking?
Sure. Yeah. I mean, obviously, we can get more. If you want to get more into your stack, then I'd be more than happy to give like more descriptive things. But without knowing anything really about it, the one thing you got to make sure your backups are really solid, and that your data, whether it's from you using a Postgres running on a VM or you're using some sort of managed data store, make sure the backups are spot on, right? Make sure your logging is actually really good. There's a really cool push around simulation testing happening right now as well.
Explain that, because I don't think I've heard that. Yeah.
So simulation testing is basically like you and some people, like, it depends on how far you want to take it. Like, some people just put asserts inside their code. So they want the code to completely fail and blow up if some non-expected behavior happens. And the idea is you would write a simulator that goes ahead and runs simulation of just bizarre stuff. That's fuzzy matching, trying to do happy paths as well as just off the wall stuff. Not so much chaos, but like off the wall stuff, and try to simulate real world scenarios and run that constantly against your applications. And then you could find that. I'm assuming you have more than one service behind the scenes. You have multiple services.
You have about 6 services running right now.
So if you have 6 services running in one, have you come up with how much downtime you would have if say the data center in Toronto goes down? Have you figured out how quickly can we come back up? What's the steps? What's the ordering? Does these things have to come up first? And stuff like that. Do you have incremental backups for, like you say, your database, or are you just doing it every hour? Is it okay if you lose an hour of code? What about caching? So there's a lot of things that you definitely should be thinking about being in one data center. That definitely puts you at a risk, as they will and do go down. And maintenance happens. DigitalOcean, I have some droplets as for personal things. Maintenance happens, and so you definitely want to reduce customer pain as much as you can there.
The one that keeps me up at night is sort of like your third-party dependencies, right? So, for example, I got bit the other day because PostHog had a defect in it, and it's an analytics tool, and it sort of broke all post calls that the application was making, and it took a nightmare to debug, right? And even though I had fixed the version, it's still sort of like it uses the web one, and it's messed up. That keeps me up. Data loss for sure keeps me up. Data loss probably is the biggest thing that keeps me up. So I have spent like a ton of money on like backups to the backups to the backups on the data side. That's for sure. What do you think? What do you think of going into a sort of a Kubernetes cluster already, or am I okay with just having simple load balancers running on simple systems like droplets, for example? App platform is basically a droplet, but it's managed, right?
Sure.
At what point, what kind of problems am I trying to solve if I go the K8 route?
Sure. So, probably an unpopular opinion is you probably don't need Kubernetes at your scale at the moment. And, if you want to share, QPS or something, or whatever, then we could probably dial that in a little bit more, but most likely you probably don't. So I think one of the benefits of using Kubernetes and what this solves, right, is if you have a lot of services, you run into other problems like service discovery. How does your load balancer manage all these services? How do these services find each other? Sure, DNS is okay, but it's brittle, right? It's very fragile if you starts changing things, and you bring up new services often. So Kubernetes kind of solves a lot of those that scale issues. Also, Kubernetes has control loops, and so one of the default deployment is actually called a deployment, and it basically you will say I want three versions of this service, and it'll make sure that those 3 services, the 3 versions of that service are always running as best as it can, of course, right? You're not running out of resources and nodes or other catastrophic issues. And so that is kind of fixed for you in a way, or is managed for you in a way. And so it handles a lot of that. There's secrets handling, right? How are you injecting secrets into your app? Is it through
just environment variables right now?
Right. And so Kubernetes offers a different solution to do that. And I'm not saying it's better or anything like that. But the problem is most managed Kubernetes, you're not going to manage the control plane. EKS and Amazon or DigitalOcean's, like they're going to manage the control plane. You're just going to manage the nodes. But every time a node needs to be updated or there's a problem, or you're running out of space because of the way you're packing services on there, because then you also have to bring in, well, can I have all my tier 1 services on one node? And the answer should be no, right? You want to spread the cone of destruction out as much as you possibly can, financially and everything else. So you add all that, you're gaining some of the thing, but you're also adding complexity and cognitive load, everything we've been talking to up to this point. You're adding other dependencies is what we were thinking. But
and you're making onboarding harder, which we started off talking about.
You are, because now when you're hiring, you're like, have you ever used Kubernetes? Do you use Helm charts? How do you JSONnet? And there's like 5 different ways that you can create resources inside Kubernetes, and we got to figure out what they're comfortable with. But then on the other hand, hey, I have a bunch of VMs. I have a load balancer. I have monitoring. If one of them goes down, I can spin up another one using basic DigitalOcean command line tools. They have an API. But you are going to be responsible for those. So if there's a bug in that code or bug and stuff, it's on you. And what does down look like? Or how do you auto scale? If you get into a cloud like, say, Amazon, you can get EC2 and node groups. You get auto scaling group where you can auto scale based on metrics. You could do the same thing easily in DigitalOcean. I'm not familiar with all of their services they offer. Whether they offer something like that or not, I don't know. But you can easily create your own. But it's work you have to do.
Right. So thanks. That is helpful, because I have made the decision not to go with K8 right now and just continue with, because I think what I'm biased by is in 2006 or so, I used to work at the University of Toronto, and me and this just 3 people really. We used to run the student information system, and one of the big problems used to be kind of like, when the course registration start, kind of like all 60,000 people used to come on at the same time and just collapse the system every single time. And it was the old IBM ZOS kind of setup, and fronted by some Tomcats or whatnot. And I remember solving that scale issue in 2 ways. One, some intelligent caching. And second, I remember seeing this Walmart guy. I forget his name right now, but Walmart used to be big back in the day in terms of technology, because they were the first kind of retail giants to sort of try out what we used to call pizza boxes, which is like buy this really, really cheap hardware, deploy it in this round robin setup, have like a load balancer in front, and Bob's your uncle. Like, you got scale right away. So I'm going back to 2006 architecture right now because it's cheap. It solves my current problem. And as you said earlier, like, why should I introduce complexity unless there's a damn good reason to do that? And right now, I just don't see it. I like the pizza box approach.
It's funny. That's how Google grew as much as they did. They bought up all the 1U Linux service that you could find in the early days, and they were all like super micros and cheap off-brand. So the pizza boxes, and they were just commodity hardware, and it worked obviously well. I don't know what their infrastructure is now or anything like that. I'm talking the early days and stuff like that. There's a lot to be said to get that scale. And do you know what I think it is too? And I think a lot of conferences and books have taught us, like you mentioned dry earlier. You don't want to premature optimize, but you don't want to get caught flat-footed. So you make sure you're planning for success. But I think it's bad advice, right? I think what you're doing is the right thing. We're gonna keep it as simple as possible with some VMs, maybe some Terraform or some Bash scripts, whatever, and we've got everything covered, and that's okay until it's not. And then going to a more complex is much easier from that point to the next point than it is going, we're going to go Kubernetes, we're going to go multi-region, we're going to go CDN, we're going to do all this stuff, and then we're going to do global caching, and then all of a sudden you realize, well, our traffic is literally 100 requests per second. We overkill. My bill is now $40,000 and we don't need it. Now I'm going to go back to just VMs and Bash scripts, and it is going to be a nightmare to go back.
I think that the saying that comes up often, and I know Amazon has it too. I think it was done by the Coding Horror. What was that guy's name? Coding Horror. He wrote this.
Oh gosh, I know who you're talking about.
You know what I'm talking about?
Yeah, I can.
With the hair. Yeah. Totally forgot. I think he made Stack Overflow.
He did.
He was the guy who made it. Yeah, completely escapes the name right now. I could Google it, but I won't. And I think one of the things that I think he said, maybe it's not an original saying, was that you defer all decisions to the latest responsible moment. So you don't make a decision unless you really need to, or I think in Amazon it's called 1-door, 2-door decisions. I think that they call it there. And I think the same idea can be applied to complexity. is that you don't introduce complexity unless you absolutely need to introduce it. Premature complexity, just like premature optimization, I would argue is far worse because going back is a lot harder.
It is. Do you know what's an interesting side effect of that, though, too? As engineers, right, we love to be creative. We love to build things. We're builders, right? But keeping it very vanilla and plain turns some people off. Like they don't want to join if it's too easy. Like they're not being able to spread their wings and be creative and do stuff. So it is a small balance, especially at early on companies, of like, all right, we can't bring on every new tech that comes out, every new JavaScript framework or anything new and shiny, because we can't support it, and no, as much as Haskell is cool, we can't build a bunch of services in Haskell because we won't be able to maintain them after one person leaves. But at the same time, and I'm speaking probably more for me, like I also don't want to join a company that's like, we do one language, we do one thing, and that's it. There's no real like flexibility and creativity, because at that point I feel like I'm an order taker. Like I'm not really solving real problems. I'm just managing software that's already been there. And so that for me is not appealing.
I do want to cover two more topics with you, but I know we're sort of running tight on time.
Okay. But I'm okay on time.
Okay. So I'll tell you a quick story on that the desire for homogeneous applications and singular languages. My first job ever, Java was kind of like the language we used to use to develop our web apps. Of course, 2004 we're talking about, and so there were programmers of different levels. Right, there were people who used to learn who knew object-oriented programming, used to like use objects, and there were people who just to shove all their business logic in JSPs. So the owner of the company sent out a memo, and I wish I had taken a picture or something of it at the time because it was unbelievable. He sent out a memo saying, even though we are using Java, I don't want anybody to use the new operator. All code should be in JSP so everybody understands it and all the logic is in one place. So we had to like rip out classes we had written so that they stayed in JSP and got compiled at servlet time, just because in his mind, he wanted kind of like lowest common denominator, right? He took it to the next level where he did not want objects in your web code. And at the time I was like, I got to get out of here, man. I can't continue working here. Like I'm going to regress. So I have seen what you're talking about there.
Yeah.
So two more topics I have. The second one is AI, but the first one is this. So I've noticed this new, it has been going on for a few years. And I think the best example that I can think of is Elixir LiveView, which if you haven't heard of it.
I have.
You have? Okay, great. So it's just for the audience. Basically you write all your code in one language, and your front end code is also written in a quote unquote back end language, and all the communication happens over WebSockets. So if you have to write a click handler for a button on the screen, you would actually program a server side function for it, and that handles it. And over the wire, it just sends back HTML or whatever it is you're doing, probably HTML. Mm-hmm. I really experimented with this even a couple of weeks ago because I had a customer who wanted like a sign up form on this website they have to go into the mailing list. And I'm like, I might use Elixir for this because I just want to experiment with it. Kind of backed out, got cold feet at the last second because I myself did not really understand the scalability of WebSockets. And this could be a high traffic page. I didn't really have the time really or spike into, are WebSockets a good enough solution for this? Do you see sort of that paradigm of programming? And there's other ones too. I think there's a new project or in development project called Zero Sync, written by another very Spolsky. That was the guy's name, by the way.
Yes.
Spolsky. Another project is called OneStack.dev, a great project. It attempts to do very similar things where you are writing your database code in your UI. And as you are sort of like writing new queries, it's smart enough to figure out what changed. So the response times are really fast. So we're going, there's some push towards like kind of like one stack development. I don't know if I'm describing it well here, but your opinion, your views on that model of development, and what do you think there's a future there? Is it worth going into it? Or are we going to continue staying in sort of these separate, isolated, but interconnected services?
Wow, it's a really good question. I'm going to be honest and I'm biased. I've used Elixir and Phoenix I actually was I got paid to actually write Elixir and Phoenix at this company called Community. I was a principal engineer there. And so I obviously have a favorable opinion of server-side code. I honestly think because of, and this is no fault for JavaScript. Obviously, like the web wouldn't be what it is without JavaScript. So I'm not, I'm definitely not one of those people that like my language is better than yours or anything. But I think because of what the complexities you and I have been talking about and the dependency problems, the pad lefts and like all these other stories, I think is driving people to go, you know what? I want to get stuff done faster. I'm already writing in Elixir inside Phoenix. Like Chris McCord is the creator of Elixir Phoenix. He actually, to answer your question about what WebSockets, he has a great video, and I'll see if I can find it to you and send it to you offline, of how much scale you actually can have with a live chat over these WebSockets. And I would tell you, you're going to be fine. You would be completely fine with scale. And obviously Elixir's built on top of Erlang, the Beam, which is, it's a very robust real-time operating system that was built for stability and reliability and all these things, because it used to be in network and phone switches and Ericsson way back in the day. But anyway, I think we're going to see more of this. I think we're going to see more and more, especially people like writing web frameworks in Rust and Go and now Zig. I think you're going to see a lot more of this server side. There's WASM and other things, that are obviously been taking off. And I think some of that has to do with the complexities of JavaScript and just which framework do I use? For example, do I spin up Vue? Do I spin up something else? Am I React? What do I have to do? And then this huge ecosystem that you have to then learn, and you'll spend. And so, as someone who's trying to spin up, just to give your example, a sign up page, the amount of time and effort, if you didn't know JavaScript very well, I'm going to spin up a JavaScript front end, and then I probably need to write a back end, and then they need to talk over an API. I'm just going to share a JSON. Then there's headers, there's JWTs, like. It just becomes this massive amount of work just to do something simple. Whereas if you take something like Elixir and Phoenix and then use LiveView, where it's server-side code, I'm in the same code base. I'm in the same thing. I'm in a controller. I'm in a LiveView. It's passed over to JavaScript. 99% of the JavaScript or the plumbing you need to make LiveView work is already done for you, and it'll all just work out of the box. It's hard to beat. It's the same reason when we were younger and Rails became so popular, and everybody likes to, I know people make fun of Ruby and Ruby on Rails or whatever, but there was a time, people may not remember, that almost every startup in America was using Ruby on Rails to feed their SaaS or their front end page, because it was just so easy to get up and running fast. I'm not saying it didn't have issues or other stuff like that, but it was so easy to go from zero to hero in no time. And I think that's what the server side does. It's why it's appealing. I'm not saying it solves every problem, but I think that's why it's appealing.
And I think Ruby on Rails, I could be wrong here, but to me, it was the first sort of framework which really took convention over configuration really seriously.
100%.
And I think a lot of credit needs to be given to that whole group for introducing that idea. So unfortunately, I already implemented it with. I am using Elixir as well. But I just ended up writing a kind of HTML controller which just submits a post response. I might go back to, honestly, one of my things that kind of worried me was, how does DigitalOcean handle WebSockets? How long do they keep those connections open? Am I going to run into issues there? And this is a customer that I really want. I don't want things to screw up. So I maybe I'll try it again on a lower risk situation. But this one, I kind of wanted to go simple HTML form with a post request. It's circa 1997. Good old form submissions. So I do want to end off with, I know it sounds cheesy, but some AI talk. I kind of want to know, how does AI fit currently in your sort of personal development workflow? Like how have you been using it?
Sure. No, I think it's a timely question, right? As much as I think a lot of engineering we would kind of maybe snicker, or we kind of maybe roll our eyes or whatever to some degree. I think a lot of people are starting to use it. So I could tell you in our job right now, my current employer, they're piloting using Copilot to help in some mundane coding tasks. Mixed results, you know what I mean? Some of the code, it's saving people some time, and some of it's not, right? And some of it's introducing errors because people are relying on a little too much, possibly. So for me personally, I went when it was available. I enabled it to try it out. I was doing a project in Rust at the time, and I was pretty new to Rust. I didn't know it that well, so I think the initial sugar high for me, I thought it was great, but for me personally, the more I used it, I felt like the more it got in my way. It was more of a distraction, and some of the times I didn't understand why it was giving me these thing, and of course I could blindly just yes, I'll accept those. So I turned it off. What I do use generative AI for in my daily life is I use it as a better Google. Instead of Google searching everything, I now get a more pointed answer instead of having to look at 20 websites. So I
sort of replaced that. So sorry, but it sort of replaced Stack Overflow for me.
Yeah, 100%. And there was definitely things like that I still use, and I'm sure everybody uses it for resumes and other things. I have seen in a more like nefarious style of it, we've seen a huge uptick in interviews of people we've been interviewing that are clearly using Chat GPT or whatever, or Llama locally while they're in the interview, and it's very obvious that's what they're doing.
Tell me a story about it. I haven't done an interview like that in a while, but give me, tell us something there.
Yeah. So I interviewing a person, asking them basic operational style questions, right? And you can hear the typing. You can see the face looking at somewhere else. And then I'll ask a question, and something logging or something, whatever. And then they'll say, yes, I would do this. And they're basically reading it off the screen, which anybody can tell.
Yeah.
Unless you're a very, very experienced teleprompt reader or something, like you do that for a living where you can hide it. And it's very paused. It feels very artificial. And the words sometimes are way too big for the subject we're talking about. Whereas if you and I are having a casual conversation, we're talking about like megs or gigs, and then they're like gigabytes, or you know what I mean, and like spelling things out. And I was like, and then you don't want to insult people, but you're like, hey, are you using any generative AI to help you today? And oh, no. And I'm like, well, because if you are, it's a disqualifier. Like, you don't need it. We can have a conversation.
Yeah.
But I've had other people tell me the same thing too, that right now they're seeing a huge uptick in it.
Yeah. I have it integrated much more into my development workflow. Not necessarily as part of my IDE, but like, it's, for example, I find it like, so this morning, or sorry, not this morning, last week. This morning, I just looked at it again. I had to write a function which sort of like, people buy tickets in groups, and if you have like a similar email, and you say you bought 2 tickets, and then later on you came back, oh, I need to buy another ticket. You buy another ticket. Now you have 2 orders, but it's from the same guy. So when the person at the club prints it, they want those 2 grouped together on the screen instead of. So it was a quick grouping function, right? And I was like, this is so. Of course, I can write it, but can I just type this into ChatGPT and it gives me the function to write? So if you are able to break down your work into small functions to write, I find it quite beneficial. I think it saved me a lot of time. That's one way. The second, which I'm experimenting with more and more, and I've had some success, is I think the TDD style, where you give it the tests and it gives you the code. That one is still, the jury's sort of out on that one, because it's not working that great right now. but I have found it has saved me a ton of time writing a lot of kind of like mundane code, like I go through a list and pick off all the ones that meet a certain criteria, then reduce it down to something else. You can actually save a ton of time doing that. So it's been a fairly positive impact on me. I tried the Amazon Q or Amazon Code Whisperer. That was bad, like really bad. Just not good. Misleading, I'd even say. Like I would go that far. But but asking ChatGPT or Llama AI some small questions to write functions, and I think that has helped a lot. But yes, overall, it doesn't solve you. And I've noticed that the bigger the ask, obviously, the more problems you're going to have with it. It's going to hallucinate really, really quickly. So if I had to draw a graph of it, it kind of shoots up as soon as you hit like a sort of like a medium complexity problem. But for kind of small complexity problems where you can describe the parameters easily, I think it works out quite well, and has probably saved me a ton of time.
Yeah, I think you're right. I do. I think there is some benefit there, and it's just going to get better. Let me ask you a question. Where are you on the camp? Are you, oh my God, it's going to replace all engineers are going to lose their jobs to AI? Or you're like, hey, we've seen the sausage, and trust me, we're years away.
Yeah, I have. So so far I have not seen the evidence that it's replacing any engineers. That's my current experience. Now, I also don't know much about this topic. And I don't know if you've seen that Netflix doc, The Social Dilemma. It came out a while back. It was about like social. So it's made by this guy named Tristan Harris, who studies this a lot. And he studies AI, he studies technology, he studies network effects. And his view is that if you had to describe AI, it is experiencing exponential growth, and it will experience exponential to exponential growth, because you're eventually going into self-feeding systems. Like the input of the right now, in the example that I gave, I was the input to the AI. It's really a one-way street right now, and there's a model that's doing something. I think according to him, we are like at the 0.01%, and it's going to shoot up, because what's going to happen is that AIs will feed AIs, and you will essentially be an observer more than an input into the system. So I don't know exactly how it's going to work, but I do trust the guy. He seems to know what he's talking about most of the time. But my lived experience is I don't think programmers are going anywhere. I think programmers are going to get more productive, but they're not going anywhere.
Yeah, I agree with you. I'm in the same camp, and nothing I've seen so far tells me that we're in danger. I'm sure a lot of businesses would like it to be better than it is, because from a cost-cutting savings, like, hey, if we can just have AI write more of the code, and we can save on engineer cost and stuff like that. But the fact is, you can't have somebody reason about product, customer obsession, delivering results, like those human things those traits, those tenets that we strive for. We're not there yet, and it's not ready, in my opinion. But I think you're right. I think as a personal assistant or other things to increase my productivity, like we were talking earlier about cognitive load, about software engineers having to know about Terraform or Helm charts or whatever. It's a great extra tool that they can help and say, hey, I need to create this Terraform to create an S3 bucket that's not public readable. How do I do that? And you can do that. But you could see this more of not a Chat GPT or something that's public or Gemini or anything, but actually your company has a trained model that it trained Llama or whatever off of your own documentation, your own wikis, and everything like that.
Yeah.
And you create this like magical. So when I was a kid, and I don't know if it's like in Canada, but in the US, when you wanted to pick up the phone and dial information, you dial 411, and you'd ask like, I'm looking for this pizza at Domino's or whatever, blah, blah, blah. And it becomes a much better 411 for internal use for people. And I think we're going to see a lot more of that.
Yeah, and we were talking about earlier about document. You mentioned documentation. I think on the SRE side, there are big implications of this. Like, for example, log parsing. I mean, we generate like gigabytes worth of logs, and sifting through them, seeing what happened. I think a lot of SREs spend a lot of time kind of like diagnosing what happened, right? I mean, I'm currently working in a system, not for my personal, but for my actual work, where like, pretty much every request results in a successful response because it's too heavy to actually process right there. So it goes into a queue. You assume success, and if it fails, you kind of reverse engineer and see what happened. It's payments, right? So it's like, yeah, it worked. Let's let it go through the chains and the banks, and if something happens, then we'll deal with it. SRE will find out, and they'll have enough data in their logs to figure stuff out. So I think in that area of software development, I think AI has a huge part to play, and I think that world is going to get impacted big time, and also the documentation part, as you mentioned.
Yeah, for observability, I would like to see definitely, and I know a lot of people are already doing this to some degree, but stuff that can be actionable. There's nothing worse than getting a page at 2 a.m. that you can't do anything about. It's not actionable. That stuff, honestly, is a pet peeve. It drives me nuts. Only time I should be paged is when the human interaction is needed. The system cannot figure out that it can recover or do something else, and so you have to do those things. I think I would like to see a lot more done in that area. And in fact, like if I could start a company right now in observability AI, I guarantee Y Combinator and other places like that have companies right now starting that are trying to solve this problem, especially with the on call. Hey, it's 2 a.m. I got this page. Should I really wake somebody up? Should I not? And then making a solid decision based off of your own data and own models. But as you know, garbage in, garbage out. A lot of companies aren't going to have a bunch of this data. So if they can train different sets of like risk, like I have tons of risk because it doesn't matter if we're down. You can go ahead and use your model to make decisions for us. Or hey, we have low amount of risk, and then the probability is a little different. So I think there's something there. I don't know exactly, but I think there's something there.
Sorry, my mic was muted. I think the worst wake up call you can get at 2 a.m. is, and this is the one that I hate the most, or I don't get them anymore because I don't work in those kind of jobs. Is, hey Zarar, can you click on this button and approve this request? I think that one is the worst one.
Or hey, this disk is filling up. Can you jump on this server and delete some files? Like those are like the worst. Like, well, what are we doing? Why are we wasting people's time?
That's right. Brad, this was a great chat. I think our listeners will definitely enjoy it. And thank you for coming on and making the time. And hopefully we can have you back and talk about maybe a couple more topics and go deep dive on them. So this has been fantastic.
Yeah, I loved it. This was a great conversation. I'd love to come back. There's definitely some other things that I would love to share about some information that I have, the experiences of startups that I think could help you.
Yeah, absolutely. Thanks again, and we'll see you again soon, listener. Goodbye.